point on this. One of the things I want to tell you guys is, there's an expectation of all students in my classes of taking the initiative and figuring things out yourself and trying to figure out how to do something if you're not sure. That's what I'm trying to teach you to be able to do. However, in my advanced classes, that is a specific expectation I have of all of you. If you're in this class, then you already should have that innate need, an innate, just that trigger inside of you to want to know where to find things. To be able to okay, I know I can do this, I'm going to go back in my notes. Or I'm going to go back in my book. If you come up with a problem that, I give you a problem or the book gives you a problem that has to do with degrees Fahrenheit and degrees Celsius, and you're like, I have no idea how to convert degrees Celsius and degrees Fahrenheit. Well, what are you going to do to figure it out? What would you do? If I gave you a problem that if I said, I want you, it is 43 degrees Fahrenheit today. I need you to find the degrees Fahrenheit. And you have no idea how to do that. What are you going to do? You're not going to circle it and come to me and say, I didn't know what I'm doing. That you're not doing. So what are you going to do? Nobody has their hand down because you're all thinking about this. What are you going to do? What are you going to do? Ada? Look back in the book, and what are you going to look for? What are you looking for specifically? How to do the problem. What are we looking for? Brendan? A conversion factor or a formula, right? Does that make sense? I mean, don't you think that you might need to know the formula of how to go back and forth between Celsius and Fahrenheit? Don't you think you might need to know that? What happens if you don't have your book? What are you going to do? You're at home. What are you going to do if you don't have your book? Colin?
We go on, it's called, I can't remember what it's called, it's KH.
Khan Academy.
Yeah. You can go on that and maybe search up a video on how to convert Celsius to Fahrenheit.
Excellent. You can look up a video. How many of you guys, if I gave you the formula, you think you could figure it out? Why wouldn't you get on your phones and be like, what is the formula to convert degrees Fahrenheit to degrees Celsius? Do you think that's something you guys could do? That's the initiative I'm talking about. So I don't want anyone to come back to me in this class or my other advanced class and say, I didn't know how to do something. You might not know how to do it. But my question for you is, did you try and figure it out? Did you go back? Did you ask somebody to help you? Did you go back in the book and look and see if you can figure it out? That is, to me, a student that deserves to be an advanced class that takes the initiative. Can you guys see that mindset? So if you're like, yeah, I wouldn't necessarily do that, then that's something that you have a goal of while you are in this class. A goal of period, but particularly in an advanced class. Okay? All right, what can I do from last night's homework for you? Valentina? So let's take a look at 48. So 48 says to us, monarch, so we're talking about monarch butterflies. So we're talking about monarch butterflies. All right, and they tell us that they go through 4 stages of life. All right, and then it says regular monarch a butterfly lives about 5 weeks. All right, I need to know that. However, migrating, this is a regular monarch. But they tell me that a migrating monarch lives up to 30 weeks. Wow, that's a big difference. Okay, so now I need this information. So I have, this is the length of the stages in weeks. All of you should have this table written down. All of you should have some sort of explanation of the rest of the information that it's given you. If you did it and you just wrote the table down and then you were like, yeah, I didn't know what to do. Well, no, of course you didn't know what to do. You didn't pay attention to everything else they said. You need all this information. All right, so then they said that we have the type of monarch. Then we have egg. We have caterpillar. We have pupa. And we have butterfly. So these are the stages. I have a regular and I have a migrating. All right, they tell us that the egg for both of them is just 1 day. They tell us a caterpillar is 2 days, 2 weeks. A pupa is 1 week. And then a regular butterfly is 5 weeks and 30 weeks for migrating. Okay, so I'm going to do all of this just so I can wrap my head around everything because I haven't done this one in a while. A says, write a fraction of the regular monarch's life spent as a butterfly. So we want the regular butterfly fraction, regular monarch, fraction spent as butterfly. All right, well, my butterfly is 5 weeks out of a total weeks of, well, here's the thing. All my total weeks, I need to add up here. So I have a total of 1 plus 2 is 3, plus 1 is 4, so this is 9 weeks. This one here is 30, 31, 32, 33, 34, 34 weeks. So I need the total number of weeks of the entire life cycle. So that information I needed to find. Because remember, my fraction is going to be my parts over my whole. The parts is our specific data that we're looking for. Our whole is our total data. Here we're talking about number of weeks. So this has to be 9. All right. Part B said we want the fraction of the migrating monarch spent as a butterfly. So that's going to be 30 over 34. They're both divisible by 2. This is going to be 15 over 17. Awesome. You found your mistake. That's great. Anything else I can do for you? Yes? Okay, so put your notes away. Let's talk about those. And I'm going to start with that. So write C notes on that. So right next to 29, if you had a question on 29, say C notes 1121. And we're going to start with that. So get your notes out and let's talk more about that. Okay. So today is the 21st. All right, we are still doing 4.3. So 4.3 continued, C-O-N-T apostrophe D continued. Equivalent fractions. So let's talk about simplifying fractions with variables. So let's take a look at number 19, Amanda, right? So let's take a look at, we're looking at page 187, number 19. No, 29, thank you. All right. So 29 said I have 6a over 6a squared. So what I want you to do is we are going to list these out expand this out. So what I want is this, the numerator stays the same, 6 times a. But what does 6 times a squared mean? What does a squared mean? Patrick? So that's a times a. Alright, so what I want you guys to do here, what I want you to do is we are going to divide by, we need to divide out my common factor. Alright, so, well, they both have a 6, so I'm going to divide by 6 for sure. How many a's do they have in common in the numerator and a's they have how many a's do the numerator and the denominator have in common? Brendan? 1. Alright, so one of those a's divides out. My numerator becomes a 1 because the a's cancel out with each other. In the future, I'm alright with you guys not, for this section, I want you showing this. But in the future, I'm alright with you guys just crossing them out. Does that make sense to you guys? When we get to that point, I'm alright with you guys crossing out. But now I want you just to show me what you're dividing out. So when I do that, my 6 becomes a 1 in both of them. In my denominator, I'm simply left with an a in my denominator. So this is 1 over 1a or 1 over a. So I would take 1 over 1a, or I would simply take 1 over a. Both of those are the same thing. Alright, let's take a look at another one. So I want you to simplify. Alright, so let's do 10 times x times y divided by 15y squared. Alright, well, 10 times x times y over 15 times y times y. So I want to kind of see you expand that out. This is called expanded form. When we expand that out. What common factor do 10 and 15 have? What common factor do 10 and 15 have? Alex? 5. I'm going to divide 5 out of both. What other common factor do these have? Now we're looking at the variables. Sarah? Yep. So my y's cancel out. My 10 becomes a 2. I'm left with an x in my numerator. The 15 becomes a 3, and I'm left with just a y in my denominator. So I have 2x over 3y. Alright, let me give you guys a couple more to do. I'm going to grab some from last night's homework. Actually, I'm going to do some that are different. Alright, so let's do 27 w squared z to the third over 18 w to the third z. So all of you guys do this, please. Now, if you want to start just with the numbers first and divide out common factors with the numbers first and then go to your variables, that's fine. If you want to do it all at one time, that's fine. Again, in the future, when we do this, we will do expanded form, but I'm just going to have you cross them out rather than showing me what you're dividing. But for now, I want you to divide them. But make sure you're writing these out in expanded form first, so you can see them and see what you can cross off for those variables. Alright, what common factor, monomial, because this is actually a monomial, because it's numbers and variables. What common factor monomial are we going to divide out? Cameron? Excellent. So 9WWZ. Alright, so I feel like the best way to do this is to go back and cross out the variables that divide out so you can see what's left. So here, those variables are left. When I divide 27 by 9, Cameron, what is my final answer? Excellent. How many of you guys got that? Questions? Yes. Z squared, because that's the final. So write the simplified with an exponent if necessary. Simplified form has exponent on variables if necessary. I'm going to give you a couple more, and then I want to move on to something else. Who needs to see what's up there? You guys cool? Brendan, you cool? Somebody give me a fraction that has numbers and variables in it. I like these, so these will get big. Like these are like puzzles to me. I like these, particularly when we get to our exponent rules. These are fun for me, so make it harder. Sophia? Go ahead. When you're done, check with someone sitting by you. The work that I'm showing you is the work that I should expect to see. Don't forget that. All right, someone tell me what am I going to do here? Addie. All right, so I have a y that cancels out, a z that cancels out. So what's my final answer? Excellent. How many of you guys got that? Okay. All right, so now I want to switch gears for a second. And let's talk about equivalent fractions again. Okay. If I said to you, tell what value of x makes the fractions equivalent. I want you to figure out what to do. So I have 5, 6, and I have x over 24. So figure out what to do that. We'll talk about it, but I want you to see if you can figure out what you would do. Talk to someone sitting by you if you're not sure. So I need to tell what value of x makes these fractions equivalent. See if you can figure out what to do here. Gosh. 5, 6. Really? You can't read that? Oh, okay, that makes no sense. You need to move up from where you move up. X over 24. I was going to say, my handwriting can be up your work. So if we're saying those are equivalent fractions, what should I be doing with both of those fractions? What should I be doing with them? Sophia? Don't I have to set them equal to each other? But don't I have to show physically they're equal to each other? Right, and then you can tell me how, right? All right, so I might do something like this. 5, 6 equals x over 24. So Sophia, how do I get from 5, 6 to whatever over 24? Why 4? Excellent, because I know that 6 times 4 is 24. Cameron, just give me a second, please. I know 6 times 4 is 24. For these to be equivalent fractions, I have to multiply the numerator and the denominator by the same number. So we know that x has to equal 4. No, it has to equal 20. Can you guys see that? All right. There's another way that we could do this that I want to teach you that you're going to need to know for one of these because you have 3 of these for homework tonight. Okay? If I say this, and this is jumping ahead in some content, but we'll eventually get to this. Last year, did you guys learn the word proportion? You guys learned about proportions? What are proportions? Here's a hint. They go with what we're doing now. They're going with what this concept that I'm going over with you is. They're going with this concept that I'm talking to you guys about. What does proportions mean? Just give it a try, Amanda. Nope. Yes, there is parts and wholes in this. I like that thought. Ada? Yeah, when you're baking, you're putting proportions of things in, but when it comes to math, when it comes to fractions, what are proportions? When it comes to math, what are proportions? Cameron? Yes, there are 2 different fractions that are equivalent. So proportions are equivalent fractions. They are equivalent fractions. All right, so while this one was very easy to figure out what x is going to be, because 6 is a factor of 24. If I give you something like this, 5, 6, and x over 32, that's not quite as easy, is it? Okay? So I'm going to show you a different way to figure this out. You're going to need this for one of these, okay? Well, first of all, what I'm going to do is I'm going to set up the proportion, which means set the fractions equal to each other. So I'm going to set the fractions equal to each other. So I have 5, 6 equals x over 32. There is, and we will get back to this, but I wanted to go through this with you because I think this pushes you a little bit more when it comes to equivalent fractions. There is a method that you always can use to solve proportions. Did you guys talk about solving proportions last year? No? Okay. So there's one method we can use. You always use it. All right. If you can see it like this, obviously you don't need to. Okay. But if you don't know what you multiply 6 by to get 30, what you can use is something called cross multiplication. It's called cross multiplication. What that means is you multiply numerator of first times denominator of second. You set that equal to the denominator of first times numerator of second. That is cross multiplication. So let's figure out what in the heck I'm talking about. So I'm going to take my numerator of my first and I'm going to multiply it by my denominator of my second. So I have 5 times 32 equals, then I'm going to say my denominator of my first times my numerator of my second. So 5 times 32 is equal to 6 times x. This works for every single proportion. And these proportions can get complicated. So now just solve. What's 5 times 32? AJ, sit up. What's 5 times 32? Ada? So this is 160 is equal to 6 times x. Now what? Now what am I going to do to finish solving this? Remember, I need to find out what x is. Now what? AJ? Divided by 6. Not 6x, just 6. So do that division. What do I get? So you guys all can do this off to the side without your calculators. So what is x equal to? Danny? Excellent. So I got 26.6 repeating. So I want you guys to keep that in mind. Because there's one problem tonight you're going to need that for. Yes? Yes, you can use a fraction for your answer. Yep, so for that to be more accurate, it would be 26 2/3. Yep, so because that's repeating, that would be more accurate. That's fine. I'll take either one. Okay? Questions on this? All right, so in tonight's homework, if you have ones like this one, where it's super easy to see, this is the work I want you to show me. How do you get to that x is equal to 20? All right, if there are ones like this, where you can't really, 6 is not a factor of 32, then you've got to use your cross multiplication. We'll get back to doing a lot more of these later on. You guys cool? All right, that's what I got for you. For once, we're not late.